Hello, in this video we are continuing our discussion of improper integrals, specifically the first type where we have an infinite range, infinite bounds of integration. So that means that we have either positive infinity or negative infinity as one of our bounds. In example 2, we're asked to evaluate the integral from 0 to infinity of x e to the negative x squared dx. So remember, the very first step with improper integrals is to rewrite it in terms of a limit. So we're going to have the limit as b approaches infinity of the integral from 0 to b of x e to the negative x squared dx. Now you have to think about how you're going to evaluate this integral. The ones that we saw in example 1 were just immediate antiderivatives. It's not quite that simple here. But we can use a u substitution. So we're going to let u be negative x squared. Du is going to be negative 2x dx. We have an x and a dx in our integral, so I'm going to divide both sides by negative 2 to get negative 1/2 du equals x dx. Now we have a definite integral, so I'm going to go ahead and find new bounds. When x is equal to 0, this means that u is going to be 0 as well. When x is equal to b, then u is going to be negative b squared. So going back to our integral, we will have this is equal to the limit as b approaches infinity of the integral from 0 to negative b squared of negative 1/2 e to the u du. So that's going to give us a negative 1/2 e to the u. This gets evaluated from 0 and negative b squared. We still have our limit as b approaches infinity. Next we plug in our bounds. Don't forget to rewrite the limit. So we have negative 1/2 e to the negative b squared, then minus a negative 1/2, so plus 1/2 e to the 0. That term, our second term, the constant term, becomes just 1/2 because e to the 0 is 1. The first term, in order to evaluate this limit, it might be helpful if you rewrote it in terms of positive exponents. So we would have negative 1/2, and this would be a 1 over e to the b squared, so I'm writing it as negative 1 over 2 e to the b squared. And then we've got plus 1/2. Now, as b goes to infinity, the exponential function goes to infinity, this goes to infinity, 1 over something going to infinity, the whole thing goes to 0. So this means that we end up getting 1/2. Now since we got a finite value, this means that the integral converges and the integral from 0 to infinity of x e to the negative x squared dx is equal to 1/2. Okay, so this is our final answer. It converges and we get our value. One more thing that I wanted to say here, instead of writing it that way, you could actually conclude that this goes to 0 just with the exponential written as a negative still, because of the fact that the exponential function looks something like this, while the negative exponential function is going to be something like this. And sorry, that should be approaching 0. Having a b squared in, or having the argument be squared instead of just raised to the first power, just means that you're going to get this sort of behavior faster. So thinking about it as a positive exponent, we think about the fact that as x goes to infinity, e to the x goes to infinity as well. So then 1 over something going to infinity is going to go to 0, or you can think of it as the negative exponential function, where as x goes to infinity, the whole thing goes to 0.